Assalamu alaikum. Bismillahirrahmanirrahim. Thermochemistry numericals. Question number 8. The heat of combustion of liquid benzene to form carbon dioxide and water at 1 atm pressure and 25 degrees Celsius temperature is minus 3268 kilojoules per mole. What is the heat of formation of liquid benzene under these conditions? This is the question number 8. While solving this question, we apply second method, that is another method. It is often convenient to calculate the enthalpy for a reaction from values of their standard enthalpies of formation of the reactants and products. The simple way that is that enthalpy of a reaction is equal to sum of the coefficients of enthalpy of formation of the products minus sum of the coefficients multiplied by enthalpy of formation of the reactants. You have to keep in mind certain things while applying this strategy. Elements in their standard states have enthalpy of formation value equal to 0. That is, if an element is in standard state, then its formation value should be 0. When balanced equation for a reaction is multiplied by an integer, the value of delta H naught for that reaction should be multiplied by the same integer. So we shall apply here this approach. At the top, write the equation for the formation of benzene. You know that formula of benzene is C6H6. So on the reactant side, write 6 carbon solid state plus 3H2 gaseous state, arrow, and after arrow benzene is in liquid state C6H6, and after that write enthalpy of formation equal to question mark. So we are to calculate enthalpy of formation of benzene with the help of this reaction. As equation number 1, write the reaction for the combustion of benzene, that is C6H6 liquid state plus 15 by 2 O2 arrow, then 6 carbon dioxides gaseous state and 3H2O, that is liquid, and enthalpy of combustion that has been given in question, and its value is minus 3268 kilojoules per mole for benzene. Now write the formula in order to solve this question, which is given in your textbook. That formula is standard enthalpy of reaction delta H naught or is equal to sum of enthalpies of formation of products multiplied with their respective coefficients minus sum of enthalpies of formations of reactants multiplied with their respective coefficients. Now, under delta H naught or write minus 3268 equal to delta H naught F CO2 plus delta 3 into delta H naught F water. These are enthalpies of formations of products multiplied with their coefficients, respective coefficients, minus, according to the equation which you have written, that is enthalpy of formation of benzene delta H naught FC6H6 plus 15 by 2 uh, O2. Now put values. You have already put the value of enthalpy of reaction minus 3268 equal to coefficient, then minus 393.5, that is enthalpy of formation of carbon dioxide, plus 3 into minus 285.8, that is enthalpy of formation of water. Then after putting the sign minus, enthalpy of formation of benzene, that is to determine, plus 15 by 2 O2, and O2 is element, so its enthalpy of formation would be 0. After writing that, under or below this equation, you solve this question. You calculate and you place delta H naught FC6H6 at one side and all other numerical values at the other side. Since both of these have negative signs, so you are to multiply the equation minus 49.6 equal to minus delta H naught FC6H6 with minus sign. When you multiply on both sides, you may say that you are to multiply with minus 1. You will get delta H naught F for benzene equal to 49.6, and definitely this value would be with a positive sign, so the enthalpy of formation of benzene would be 49.6 kilojoules per mole. So that was second approach. It is quite simple, but I have doubt here that whether in reduced syllabus this approach is allowed or not. So that's why I have solved my previous questions by applying chemical equations method. That is, that method is a bit difficult because you are to write balanced chemical equations for a number of compounds, and while writing those equations you may commit some mistake, and as a result there may be loss of time and loss of marks as well. So it is better, although that is difficult, but in spite of that it is better you are to approach the same previous method that we solved most of our problems. Not easier, but I think that if you do again and again, you can overcome the difficulty and you can get a command over solving such problems. So I hope that, like previous videos, this would also be helpful to you. Thank you so much. You may solve uh, other question also applying this technique. So where you have written equations for many reactions, you can apply many of those to many of those questions, and this technique also. That is simple one, and I think that it is somewhat easier. Only you are required is to write equation that is demanded by the question, and then those species which are present on the product sides, their enthalpy of formation values, and those substances which are present on the reactant side, their enthalpy values, and then you may calculate any one value that is missing. Thank you. Allah Hafiz. Pakistan Zindabad.